Hello everyone, in this video I will talk about bending beam Rheometer test. We often call it Ppr test. When it's cold, pavements contract and build up internal stresses. If this contraction occurs fast enough, the pavement may crack because it doesn't have time to relax these stresses. This type of crack is called thermal crack or transverse crack. This is because the direction of the cracking is always perpendicular to the direction of traffic, as shown in this picture. There are two mechanisms that can cause thermal cracking. The first one is called a single thermal cycle below the critical temperature. A single severe drop in temperature can cause stress to quickly build up to a critical point to cause cracking, and this is called a single event low temperature cracking. And this particular temperature associated with these critical stresses is called a critical temperature. The second mechanism is called thermal cycling above the critical temperature. Repeated thermal contraction and expansion can cause stresses to build up and eventually cause cracking, although this happens while above the critical temperature. And in both cases, the failure mechanism is essentially the same. That is, thermal shrinkage initiates and propagates cracks in the asphalt binder. The Ppr test is designed to measure the stiffness and the rate of stress relaxation at low temperatures. These parameters are important indicators of the asphalt binder's ability to resist low temperature cracking. Asphalt binders that are not too stiff at low temperatures and also able to relax the build-up stresses are desirable. The Ppr test measures the midpoint deflection of a simply supported asphalt binder beam when it's subjected to a constant load applied to its midpoint. The process of Ppr test is described in ASTM D6648 and Asphalt T313. The test system consists of a loading frame, a controlled temperature bus, and a computer-controlled data acquisition unit. This figure shows a schematic illustration of the experimental setup. This is a real picture of the experimental setup. And because thermal cracking often happens later in the pavement life, so before we do Ppr test, the sample needs to go through both the short-term aging process and the long-term aging process. Basically, we need to conduct rolling thin film oven test and the pressure agent vessel test on the samples. And also, thermal cracking often happens when the temperature is low. So the test temperature is the minimum temperature of the asphalt binder plus 10 degrees Celsius. We increase the test temperature by 10 degrees Celsius in order to reduce the testing time. Remember that when we learn the viscoelastic material, there is a time temperature superposition principle. So the test results obtained at a higher temperature and a shorter load duration are equivalent to the tests performed at a lower temperature and a longer load duration. The basic Ppr test uses a small asphalt beam that is simply supported, and then the beam is immersed in a cold liquid bath, and a load is applied to the center of the beam, and the deflection is measured against time. And the stiffness is calculated based on the measured deflection. and also how the asphalt binder relaxes the load-induced stress is also measured. You may wonder how to get the creep stiffness ST based on the measured deflection. So what's the relationship between these two plots? So the deflection versus time is what we measured directly from the experiments, and based on this plot, we can plot the creep stiffness ST versus time. So the formula is given to you. So this is a formula to get ST based on the measured delta T. So delta T is the deflection at time T, and ST is the creep stiffness at time T. And the other terms, P, L, B, H, all of them are just constants. L is the distance between two beam supports, which is a constant. It's 102 millimeter, and B is the beam width, which is 12.5 millimeter, and H is beam thickness, which is 6.25 millimeter. And P is the applied load, which is a constant during the experiments. You can get the value of N from the experiment. Okay, so this is how to plot the creep stiffness based on the measured deflection. And this plot here, which is the logarithm of creep stiffness versus the logarithm of loading time, this plot is called the master stiffness curve. Creep stiffness is a measure of the thermal stresses built up in the asphalt binder resulting from thermal contraction. If these stresses are too large, cracking will occur. So a higher creep stiffness value indicates higher thermal stresses built up in the asphalt binder. So the slope of this master stiffness curve, which is designated by the letter M, we call it M value, which is the slope of this curve, is a very important parameter. It's a measure of the rate at which the asphalt binder relieves the built-up stress through the plastic flow. So one of the goals to do this Ppr test is to get this M value.